All right, so now we come into the classification of tornadoes themselves. So tornadoes are classified based on the most intense damage that they produced. So in that respect, they're pretty similar to the Mercalli scale for assessing earthquake intensity, if you guys remember that. So in earthquake measuring, we had two different scales, one measuring pretty much how strong it was overall, and then the other one based on how much damage it caused to the area. In the case of tornadoes, we just have the one scenario where it is assessed how much damage they cause to the area in which they occur. So the scale that is used is called the enhanced Fujita scale. So that scale goes from the number 0 to 5. So 0 is going to be the least amount of damage done by a tornado, and then 5 the most amount of damage done by a tornado. Thus far, 5 has been the most damaging. I think there is still possibility of growth if we have anything above that in the future. But thus far, that is the most amount of damage. So if you guys need to, expand that specific slide or look at the one in your book, which is a little bit different but basically the same, by all means do so. It tells you what the wind speed is for each classification, level, the amount of damage in terms of minor damage or extreme damage, and what specific things does that mean about maybe lives lost or just overall infrastructure loss. Okay, so the scale itself is based on a Fujita scale, which used to be the previous scale done, not the enhanced Fujita, but just Fujita. And it is based on the damage experienced by 26 types of buildings, by towers, by poles, and by hardwood and softwood trees. So it changes, again, it goes from 0 to 5, depending on the amount of damage felt by 26 types of buildings, towers, poles, hardwood, and softwood trees. Okay? So the occurrence of tornadoes itself happens mostly just in North America. Pretty much anywhere else in the planet, we barely see them. A few of them happen in Bangladesh, which is next to India to the east of it. But apart from that, we don't see tornadoes pretty much anywhere, which is interesting. So tornadoes happen within the U.S. They happen somewhere between the Rockies and the Appalachians, or they're the most common there, I should say. And that area is usually named Tornado Alley. So that's going to be pretty much in the Great Plains, ranging from pretty much Oklahoma all the way up to the Dakotas, and also influencing like Missouri, Illinois, Indiana, whatnot. Okay. Let's see. Tornadoes that happen over water are usually called waterspouts, and they tend not to be nearly as damaging, obviously. They're pretty cool to spot, and you actually can see them a lot in Florida. As you're seeing here in the graph, you do have a few amount of tornadoes in Florida as well, and many of the waterspouts can be seen from Florida itself. Tornadoes are most common during spring and summer times. And because they are associated with storms or thunderstorms, they tend to happen in the afternoon and evenings for the most part. They also happen in Canada, as you're seeing here on the picture on the right. And the places where they happen the most in Canada is going to be in Alberta, Saskatchewan and Manitoba, and a little bit in Quebec and Ontario towards the Great Lakes. Right, so blizzards. Blizzards is going to be the next process we're going to talk about. So blizzards are basically severe winter storms in which large amounts of snow is driven by high winds to create low visibility for an extended period of time. So this, again, snow does not necessarily need to be falling. It could have been already, deposited on the ground, and it simply may be carried by these high winds. The picture that I have on the right is basically showing you the different wind kind of patterns that we have seen throughout the years that have been recorded. So the main four that your book points out are going to be the Alberta Clipper, which is one of the colder and drier ones, but you also have the East Gulf one, which is actually responsible for a lot of damages, and it tends to be a little bit moister. You have the Colorado one, and then you have the Pacific ones, which also tend to be a little warmer than the Alberta Clipper and tend to cause a lot of damage in the eastern part of the US as well. So a blizzard is defined differently in the US than in Canada. So in the US, a blizzard has to have winds over 56 kilometers per hour. The visibility has to be less than 4 kilometers, and then it has to last for at least 3 hours. And then in Canada, a blizzard needs to be or have winds of over 40 kilometers per hour. The visibility has to be less than 1 kilometer, and then it has to last for 4 hours or more. So it looks to me like the US has a little bit kind of stricter policies in that sense. So a blizzard is less likely to occur in terms of the definition from the US than from Canada. Okay. In either case, however, there is no need for new snow to have developed, as I said before. You could have ground blizzards, in which case they develop every year, many times in Alaska, Antarctica, parts of Canada, and the Great Plains in the US, where snow has already fallen and it accumulates in large volumes. So with just simply the winds carrying the snow to different places, it creates a blizzard. Okay? So what is the most dangerous about the blizzards is going to be the wind chill effect, which makes them more dangerous than other storms. In fact, blizzards tend to be one of the processes that kills the most amount of people, that has the most amount of deaths associated with it, just because of the temperature factor and more specifically because of the wind chill effect that they have. So a few examples: in Saskatchewan in 1947, there was a storm that lasted for 20 days that buried a train in a 1 kilometer snowdrift. That's how long the snowdrift was. It buried this train about 8 meters high. 8 meters is like 25 feet, more than 25 feet. Another major storm that has been recorded and not as well known of, or not as well recorded at the time, was the 1888 blizzard, which killed 400 people and paralyzed the northeastern US for 3 days, with snow drifts that reportedly were as high as the second floor of buildings. Granted, the second floor of buildings during that time was probably a little lower than today, but probably not much more lower than today. So a specific type of blizzards that we call today are the nor'easters. So the nor'easters are blizzards in the eastern coast. Blizzard of the 93, for example, the blizzard of the 93 killed 240 people from Alabama to Maine. So 1993, obviously. And that specific storm cost the U.S. more than $1 billion in damages. And then, only 3 years after that, the blizzard of 1996 killed 100 people, and it cost the U.S. $2 billion. I believe that blizzard was a little bit more northerly, so it didn't cause as much death, but it caused more property damage. So you see that they are pretty major in terms of overall death count, and still something to be taken very seriously. Associated with blizzards are ice storms. So for an ice storm to occur, you need 3 main things. So you need ample moisture in the warm air mass south of the front. Okay? You also need a warm uplifted over the cold shallow layer. So as you're seeing kind of here in the picture, you have this cold front underneath right here, and you have kind of like an occluded front, right, where you have an envelope of this warmer air in between. So yeah, you're sort of seeing that happen. The warmer air is being uplifted over that cloud of the colder layer, and then objects on the land itself need to be already close to freezing or at freezing. So pretty much in this freezing rain stage is where you would like to see things be in order to form an ice storm. Okay? So you have cold up top, moisture and warmer area in the middle, and then enough like not a very large amount of space for the cold to go back to freezing, but enough room for the air to be cold enough to freeze stuff once it precipitates and falls into the ground. Okay? All right, so again, they're defined as prolonged periods of freezing rain. There are certain cases where, or certain places where coatings of ice have been said to be between 15 and 20 centimeters. And that happens a lot here in Idaho, actually, in certain areas, a little bit more rural, but still. In Texas and in New York. Actually, in New York and Pennsylvania, this is fairly common to occur. So more propense regions to this type of hazard are going to be the Columbia River Valley. So this is partly why we get it here sometimes, because we're near it. The South Central Great Plains, the Ohio River Valley, the Mid-Atlantic and New England states, so as I was saying before, and some of the Atlantic provinces and the St. Lawrence River Valley in eastern Canada. Canada is very affected by this. In fact, here's a few examples as you're seeing there on the slide. So a few examples: the Great Northeastern Ice Storm of 1998. It lasted about 6 days. In it, 45 people died. 5.2. This is million. Sorry. I'll correct that in a second. 5.2 million people lost power, and then $6.2 billion were lost. 80% of the losses, so 80% of that $6.2 billion was losses from Canada, not from the US. But again, it affected both the US and Canada. So this is still not 6.2, but what is it, like $5 billion of dollars basically was the amount of Canada's slice. Is still Canada's costliest disaster in history. So it didn't just affect obviously people, but it affected croplands majorly, and also power outages happened. A lot of the heat system actually completely fell through in some of the cities, and so it was pretty major from my understanding. I'm gonna correct that before I upload it, by the way. Did that, so you guys have the updated version, and now we move on. So fog is the next hazard. So we should all pretty much be familiar with fog. I myself am very familiar because back home, since I lived in very high altitude and it's a very moist area, fog was very, very, common. So fog is basically just a cloud that is in contact with the ground. It can be hazardous when, visibility is obscured, or when there are pollutants that are added. So with pollutants that are added and then are pretty much encapsulated by the water vapor, as water vapor is very good at keeping those pollutants, it becomes smog or fog. So smog is going to be smoke with fog kind of conjunction, and then fog is going to be volcanic gases with fog kind of conjunction. So if there's any volcanic activity going on and there's a lot of fog, then those gases from the volcanic activity can be retained within it. So it can be pretty hazardous in that respect as well. However, the most kind of damaging thing, or the most hazardous thing from fog, is definitely the visibility being obscured. And this is not necessarily because you lose sight or anything, but because a lot of accidents can happen during this time. So in North America, the most common places where you have fog are the Pacific New England, Atlantic Canada, and the Appalachians. It can also happen in the Pacific Northwest, in Washington and Oregon, a little bit in California, but not as much. So a few examples of accidents are going to be the runway collision in the Canary Islands in 1977. Two different airplanes were in the runway and they crashed, killing about 583 people, which I believe is the largest, airway death toll. And then another ship collision in St. Lawrence River in Canada of two different ships in 1914, which killed 1,014 people. Nowadays, we have better technology so that we can avoid such collisions, but it still causes a lot of injuries and vehicle